uh, I'm gonna call this we made it to chapter 19, the last section, 19.5 macros, which technically speaking isn't the end of the book, but it is the last new content, seemingly. Chapter 20 is just a project. So this is it. And they put macros all the way at the end. Okay. We've used macros like print line throughout the book, but we haven't fully explored what a macro is and how it works. The term macro refers to a family of features in Rust, declarative macros with macro_rules, and 3 kinds of procedural macros. The first one, we have the hashtag square brackets derived inside of it. Macros that specify code added with the derived attribute used on structs and enums. Yes, we've seen that. Attribute-like macros that define custom attributes used on any type. Number 2, attribute-like macros that define custom attributes usable on any item. Not sure if I've seen those. Number 3, function-like macros that look like function calls but operate on the token specified as their argument. That we've seen all the time. We'll talk about each of these in turn, but first, let's look at why we even need macros when we already have functions. That's one thing I've never actually considered. Why do we need macros? Okay. The difference between macros and functions. Fundamentally, macros are a way of writing code that writes other code, which is known as metaprogramming. In Appendix C, they're referencing appendixes now. Okay. In Appendix C, we discussed the derived attribute, which generates an implementation of various traits for you. We've also used the printline and vec macros throughout the book. All of these macros expand to produce more code than the code you've written manually. Metaprogramming is useful for reducing the amount of code you have to write and maintain, which is also one of the roles of functions. However, macros have some additional powers that functions don't. Okay, we're about to learn what macros can do that functions can't. Let's see what it is. A function signature must declare the number and type of parameters the function has. Macros, on the other hand, can take a variable number of parameters. We can call printline hello with one argument, or printline hello, comma, name with 2 arguments. Also, macros are expanded before the compiler interprets the meaning of the code. So a macro can, for example, implement a trait on a given type. A function can't because it's called at runtime, and a trait needs to be implemented at compile time. Let's rehash that because I think I got some of it, but I'm not sure if I got all of it. So one thing that macros can do that functions can't is the arbitrary number of parameters that you can pass in, or arguments that you can pass in. Print line, they did the example with hello, that's 1. And then you have the hello, which is interpreted string, and then you have the actual thing that goes into the string. So that's 2 arguments. I haven't seen a function do that yet. And then also the second point was that macros are expanded before the compiler interprets the meaning of the code. So I'm not exactly sure what that means. It could mean that because it's interpreted before the compiler interprets it, or macros, because it's expanded before the compiler interprets it, it seemingly morphs into whatever it needs to be before a compiler can throw an error. But functions can't do that because they're called at runtime. That one's still a little confusing to me. Moving on. The downside to implementing a macro instead of a function is that macro definitions are more complex than function definitions because you're writing Rust code that writes Rust code. Due to this indirection, macro definitions are generally more difficult to read, understand, and maintain than function definitions. Alright, so here they're just going over the pretty standard. This is metaprogramming. You're writing Rust code to write Rust code. As such, the bar in terms of difficulty level is a little bit higher than functions when it comes to reading, understanding, and maintaining. So all three blocks, they're just higher. Another important difference between macros and functions is that you must define macros or bring them into scope before you call them in a file, as opposed to functions you can define anywhere and call anywhere. So a macro must be brought into scope before you call them in a file. That sort of makes sense because it's expanded before compile time. But I'm not exactly sure what that means. Functions can be defined anywhere. Yes, we know that. But it seems like macros cannot be defined anywhere. They have to be brought into scope before you call them in a file. But it's compiled. Is there a runtime thing? I'm not sure. Declarative macros and macro_rules for general metaprogramming. And it begins. The most widely used form of macros in Rust is declarative macros. These are also sometimes referred to as macros by example, macro rules, macros, or just plain macros. At their core, declarative macros allow you to write something similar to a Rust match expression. As discussed in Chapter 6, match expressions are control structures that take an expression, compare the resulting value of the expression to patterns, and then run the code associated with the matching pattern. Macros also compare a value to patterns that are associated with particular code. In this situation, the value is the literal Rust source code passed to the macro. The patterns are compared with the structure of that source code and the code associated with each pattern. When matched, replaces the code passed to the macro. This all happens during compilation. I see. Basically what I'm getting here is that for declarative macros, they're like match patterns when you pass in Rust code and then you have your different arms. And then you sort of kind of just matching the syntax of what the Rust code is. So you can match it to an arm and then expand it to whatever you want it to be. That's what it sounds like. And that all happens during compilation. Okay? To define a macro, you use the macro rules construct. Let's explore how to use macro rules by looking at how the vec macro is defined. Chapter 8 covered how we can use the vec macro to create a new vector with particular values. For example, the following macro creates a new vector containing 3 integers. And we've seen this multiple times. And they didn't have to specify the type, but they did. Okay. We can also use the vec macro to make a vector of 2 integers or a vector of 5 string slices. We wouldn't be able to use a function to do the same thing because we wouldn't know the number or type of values up front. So yeah, one thing I forgot to mention is that with macros, as they just described with vec, is we already talked about the number of parameters or arguments that you can pass in, right? But we didn't talk about how you can pass in different types of things. Like you can create vectors of integers, you create vectors of strings, other structs, like that. You can't do that with functions. Functions need to know the type. I mean, yes, you can do with generics, possibly, but it's still kind of iffy. Listing 19-28 shows a slightly simplified definition of the vec macro. Alright, so let's see what they have here. Macro export. They have a macro defining a macro. Seemingly. But still, let's see. Macro rules. Vec. $, X expression, star, probably like regex or something like that. So you can pass in as many things as you want. Let mutable temp vector equal. They create a new vector under the hood. And then they push the x's. And they do it star time. So it's just repeating the push over and over and over again. Just filling up a new vector. And then return the temp vector. That would make sense. Note, The actual definition of vec macro in the standard library includes code to pre-allocate the correct amount of memory up front. That code is an optimization that we don't include here to make the example simpler. So yeah, just keep in mind that this isn't the exact definition of how vec is defined, or that macro. They have some optimizations that they didn't want to show because that would convolute or make the example more convoluted than it needs to be. So let's go over what it is. The hashtag square brackets macro underscore export annotation indicate that this macro should be made available whenever the crate in which the macro is defined is brought into scope. Without this annotation, the macro can't be brought into scope. Okay, so this is what they meant by bringing it into scope. That has to be defined somewhere. We then start the macro definition with macro underscore rules and the name of the macro we're defining without the exclamation mark. The name, in this case, vec, is followed by curly brackets denoting the body of the macro definition. So going up here, saw this to make sure it gets brought into scope. We have this here, which I guess is just the macro that we're using. And then here's the name. And then we have the brackets to have the body of the definition of the macro. Okay? The structure in the vec body is similar to the structure of a match expression. Here we have one arm with the pattern. That's a long pattern. I'm not going to try to read that. Followed by the arrow and the block of code associated with this pattern. If the pattern matches, the associated block of code will be emitted. Given that this is the only pattern in the macro, there is only one valid way to match. Any other pattern will result in an error. More complex macros will have more than one arm. So just to be clear, here's where they're showing the arm. And then this is the code associated with the arm. And there's only one arm, so everything should match there. Well, I guess it doesn't really have to because it's not a match expression explicitly. But yeah, that's the only thing that matches. Valid pattern syntax in macro definition is different than the pattern syntax covered in chapter 18 because macro patterns are matched against Rust code structure rather than values. Let's walk through what the pattern pieces in listing 19-28 mean. For the full macro pattern syntax, see the reference. Oh, the reference. Ugh. Okay. So first, a set of parentheses encompasses the whole pattern. A $, is next, followed by a set of parentheses that captures values that match the pattern within the parentheses for use in the replacement code. Within the $, parentheses is the $x : expression, which matches any Rust expression that gives the expression the name $x. The comma following $parentheses indicates a literal comma separator character could optionally appear after the code that matches the code in $parentheses. The star specifies that the pattern matches 0 or more of whatever precedes the star. Okay. So if I read that correctly, I believe the first parentheses just denotes the start of the match. Like everything that you're trying to match against goes inside. Or you can say that's the start of the arm. And then here, this $ parentheses, everything within here is going to be sort of the syntax you're trying to match against. Right? Yeah, seemingly. And then this part is the actual expression, which is anything that equates to something, a value, at least in this case. And then the star denotes that this match, like this thing here, can be repeated. Hold on, I skipped the comma. The comma notes that there's a optional comma afterwards, and the star notes that this can repeat as many times as it likes, 0 or to infinity. And then we come down to here. When we call this macro with vec 1, 2, and 3, the $X pattern matches 3 times with the 3 expressions 1, 2, and 3. Now let's look at the pattern in the body of the code associated with the arm. Temp vec dot push. Within the $parentheses star is generated for each part of the match. $parentheses in the pattern 0 or more times, depending on how many times the pattern matches. The $X is replaced with each expression matched. When we call this macro with 1, 2, 3, or vec 1, 2, 3, the code generated that replaces this macro will be calling the following. Let mutable temp vec equal new vector, and then you're pushing 1, 2, 3, and then returning vec. So let's go back to here real quick so we can see that. So seemingly, each match calls this arm. No, because if each match called that arm, then we would have new vectors 3 different times, and we don't do that. This arm, this part gets called for each expression that's passed in, each expression that is matched. So that was what we said earlier, and that seems to be correct. So at the start of it, given that this is matched, we create a mutable temp vector, and then for each expression that's coming through, which is 3 in case of 1, 2, and 3, we run this bit of code, and this gets substituted with the values, the expressions, and at the end of it, we return the temp vec, which would give us this scenario. Okay, that makes sense. We've defined a macro that can take any number of arguments of any type and can generate code to create a vector containing the specified elements. There are some strange edge cases with macro rules. In the future, Rust will have a second kind of declarative macro that will work in a similar fashion but fix some of these edge cases. After that update, Mac rules will be effectively deprecated. With this in mind, as well as the fact that most Rust programmers will use macros more than write macros, we don't discuss Mac rules any further. To learn more about how to write macros, consult the online documentation or other resources such as the Little Book of Rust Macros. And I've never actually heard of this book. And this is all black? Why did they change the layout? Oh, this is written by somebody else. That's why. It's not part of the official rustlang.org. I see. Understood. So a few things they noted is that, one, people are going to use macros more than they write macros, which is a definite because that is sort of confusing in terms of how to write it. We looked at it. It was this thing. Another thing they note is that if you really want to learn more about macros, you can reference this book. And there's a few edge cases that exist when using macros or trying to build your own macros. They didn't really go into detail about it. However, they're trying to fix it, and as soon as they write something else to replace this model, this is going to get deprecated. So I'm not even sure if it's worth learning. Procedural macros for generating code from attributes. The second form of macros is procedural macros, which act more like functions and are a type of procedure. Procedural macros accept some code as an input, operate on that code, and produce some code as an output rather than matching against patterns and replacing the code with other code as declarative macros do. I'm not sure if I understood that. Hold on. Okay, I think I get it. So they're stating here that procedural macros, they accept some code as input, and then they operate on that code and produce some output, whereas the other ones took the inputted code and then expanded it to be some other type of code and then ran the newly expanded code. So yes, this is very different. The three kinds of procedural macros, custom derived, attribute-like, and function-like, all work in a similar fashion. When creating procedural macros, the definition must reside in their own crate with a special crate type. This is for complex technical reasons that we hope to eliminate in the future. Using procedural macros look like the code in listing 19-29, where some attribute is a placeholder for using a specified macro. Oh, it's those type of macros. I see. And I'm starting to get a sense why this is at the very end of the book, because for technical reasons, there's a lot of things that are complicated about this that probably shouldn't exist. All right, so this is what it looks like. Moving onward. The function that defines a procedural macro takes a token stream as an input and produces a token stream as an output. The token stream type is defined by the proc macro crate that is included with Rust and represents a sequence of tokens. This is the core of the macro. The source code that the macro is operating on makes up the input token stream, and the code the macro produces is the output token stream. The function also has an attribute attached to it that specifies which kind of procedural macro we're creating when we have multiple kinds of procedural macros in the same crate. Okay. So as we said before, procedural seemingly takes your input as Rust code and then operates on it and then produces Rust code and then like runs it, something along those lines. It seemingly uses token stream to like tokenize the input, and a token stream is defined by the prac macro, which is included in Rust, but it also seemingly does that for an output as well. So you just have two sets of token streams. Let's look at the different kinds of procedural macros. We'll start with a custom derived macro and then explain the small dissimilarities that make the other forms different.